Okay, so we're going to start Thursday by talking about force production. We've got a few different things that we're going to talk about, but they're pretty straightforward. So hopefully, as we go through this, you'll be able to understand. Now, one of the first things that I want to remind you of is this figure here, and we talked about it to some extent in 220, but maybe not quite as in depth. But I want you to take a minute and look at this figure. And on this figure, there are essentially three different I guess areas or events, that sort of thing. I'm not sure what the right word, the right word's not coming to me right now. But we've got from here to here, and then from here to here, and from here to here. So we've got 1, 2, and 3. Now notice on the x-axis we have stimuli. On the y-axis we have voltage. So that's just kind of electrical activity. And then down here we've got a muscle, and then each of these little circles represents a motor unit that's activated. Okay, and then on the bottom here again we've got time, which what's going on here is that over time we're increasing the stimulus, and then we've got tension or force. So notice that if we don't hit threshold, or no matter how big if the stimulus is below threshold, we don't recruit any motor units. So these first two, we're not recruiting any motor units, so there's no force production. But then as we hit threshold up until we hit maximal threshold, we start to recruit motor units, okay? And so at the beginning it's 1 or 2, and then we do a couple more until we get all the motor units recruited that are possible. Once we hit that maximal stimulus, it doesn't matter if we increase the stimulus. And what we mean by maximal stimulus is the stimulus that's required to recruit every motor unit. And so let's just say it's 7, whatever that is, 7 somethings. Okay, it doesn't matter if I put 8, 9, 10, 1,000, a million. I can't recruit any more motor units, and therefore the contraction peaks out, right? And we can't exceed that. Okay, and so we've got to hit threshold, but once we hit threshold, as we increase the stimulus, eventually we'll get to a point where we're going to recruit all the motor units and we won't be able to increase force at all. Now, as we talked about last time, there's a relationship between force and velocity. Okay, so the faster the velocity of contraction, the lower the load, right? So just think about bench press. If you have just the bar compared to the bar with a couple of 45s on each end, the speed with which someone's going to be able to perform that exercise is going to be very different. Okay, when there's very little weight, someone's going to be able to push the bar up and down really fast, whereas when there's a lot of weight, it's going to slow down. And eventually you get to max, where the bar is not moving anymore. You're generating force, but the bar is not moving. So another way to look at this with force and velocity is eccentric and concentric contractions. Okay, and in both of these, they're isotonic contractions, and what we're doing is we're changing the length of the muscle. And so with this, we will either lengthen it, which is an eccentric contraction, or we'll shorten it, which is a concentric contraction. Okay, now we have different velocities here. We have different force production. Now, the force velocity curve essentially states that the force the muscle can create decreases with increasing velocity. Okay, while the force the muscle can resist increases with increasing velocity of lengthening. With concentric contractions, we are actually producing force. Okay, we're shortening the muscle, whereas with eccentric contractions, we're lengthening the muscle, which means we're actually resisting force. Okay, and so just imagine that you're getting ready to do a bicep curl. Okay, as you bring it up, you're doing concentric contractions with your biceps, but as you go back down, because you don't want to go, especially if you're preventing it from going super fast, you've got an eccentric contraction because you're trying to resist the lengthening of your muscle. Now, several characteristics also affect the velocity and the force relationship. Okay, so muscles that have a larger cross-sectional area produce more force for a given length. Okay, so we have a small muscle in the dark blue line and a larger muscle with this greenish color. Okay, and so for a given length, we produce more force with a larger muscle. That seems pretty straightforward. Okay, a larger muscle also produces more force for a given velocity. Okay, again, bigger muscle, same velocity, everything else is equal, more force. Now we're going to change, instead of going area, we're going to talk about length. Okay, so long muscles produce force over a greater range of lengths. And I think that makes sense, or hopefully that makes sense, because if I've got a longer muscle, I've got a wider range of lengths that I can accommodate to produce force. Similarly, long muscle fibers produce greater velocities for a given force. Okay, so they can contract a little bit faster when producing the same amount of force. And that's where we're going to end on this force production for now.